All right. Annoying. Okay, it seems like it's back, at least on my end. Let me open up my own Twitch page though, just to be sure. Okay, it seems like we're back. Okay. We're back? All right. Thank you, Anders. I don't know why my OBS just did that. Oh, there's a new first. Congratulations, Messi. Yeah, I mean, I guess my stream crashes. There's a new first that's up for grabs, so. Good job on getting that. All right, so this is the solution that Anders sent. Let L be A union B, R be B union C, X be L union C, Y be A union R. Okay, so yes, you did split it up to this degree. I was wondering if we would have to do that to be rigorous. So, hey Cloud, how's it going? A is a subset of L, and L is a subset of X. So A is a subset of X. Okay, yes. So maybe clear? Okay. Good, I guess. All right, well, it's better than being bad, you guess. So B is a subset of L, and L is a subset of X, so B is a subset of X, okay. And C is a subset of X, okay. Just by our definition of union here. By 2, 3 in the definition of R, we get R as a subset of X. So we're talking about B and C, which make up R. Since B and C are both subsets of X, then R must be a subset of X. Okay. Transitivity. Okay. By 1 and 4 in the definition of Y, 1 is A is a subset of X. 4 is that R is a subset of X. We get that Y, their union, must be a subset of X as well. Okay. R is a small set that contains A and B. Or wait, R is B and C, right? Well, I guess it's both, really. But I spy that I only looking at this up here, I guess. Okay. No, it's all good. 1 and 4 in definition of Y. So A is a subset of X, R is a subset of X. We have Y is equal to A union R, so Y must be a subset of X. It's the fourth line. Yeah, I'm trying to keep everything straight in my head, so I'm like trying really hard to like refer back to things and like reread them. C is a subset of R by definition. So C is a subset of Y. Okay, so this is repeating the same argument that we did for lines 1 through 3. For the same reason, B is a subset of Y. And A is automatically a subset of Y because it's already in that union directly there. So then by 8, 7 in the definition of L, because B is a subset of Y, A is a subset of Y, in the definition of L, A union B, it must be that L is a subset of Y. Eight, 7. I understand this should be right. I'm just trying to understand the actual mechanics of why it's right. I'm sure it's the same exact logic as up here. I just need to go through and reapply it again. B subset of Y, A subset of Y. And A union B is L. So L is a subset of Y. Okay. Makes sense. And this is like, I guess, implicitly using that smallest set thing. By 9, 6 in the, or I guess not necessarily implicit if we're saying the definition, but by 9, 6 and definition of X, X is L union C. So we have C is automatically a subset of Y. We had the L subset of Y, so that means that their union must also be a subset of Y. Definition L also contains A and B, so we showed, so O has to be inside L. Or L's inside Y, yeah. 5, 5. No, it's all good, Anders. So we've shown that Y is a subset of X, and that X is a subset of Y. Oh, hey, look at that. You can't speedrun chat. It's all good. Since they're subsets of each other, they must be equal to each other. Okay, yeah, so I can see why you're saying that I missed some steps here. Yeah, I'm definitely, I've done very few proofs involving sets before, so I'm not very up on the, I guess like the lingo or how you usually format proofs like that, but I'm glad I at least kind of got the idea of it. Yeah, fair enough. Thank you for showing me like the written out answer. Armenian psychologists, do you conduct statistical analysis for thesis research? I've never done a thesis, so I can't say I've done statistical analysis for a thesis. So. My background in stats is I've done like your basic stats class where you do like Z tests and T tests and the like, and I've done a calculus-based stats class where you go into like PDFs and CDFs. Really? What was the answer, Brian? You say you do this exact proof with a supremum infimum instead of union. Really? The guy wrote the question wrong? Oh, no. Okay. Well, that makes sense then. Glad we figured it out. Or that pen did. I didn't do anything. It was a minus? That'll do it. So yeah, Armenian psychologist, I'm not, I don't have that advanced of a knowledge of stats, I guess. It sounds like, I think I remember you asking a question that was kind of out of my depth but before, so I'd be nervous that as to whether I could help you out again, or whether I could help you out this time. But I have some knowledge of stats. I haven't done a thesis though, so it's, you wouldn't want to take my advice as gold. Oh, for associativity of supremums and infimums. Okay. I didn't realize that you would do it like that, but I guess that makes sense. Yeah, there may be someone around who can help you. I'm not... I have a hard time like recommending someone in the streamer in particular, but someone wants to like step up. And it's more than welcome. There's a lot of proofs like this in different contexts. For number theory, it is the same for least common multiple. So it's, oh, okay, that's the universal property thing. Cause yeah, well, when the other person, I forget their name already, asks about like what the problem means, and I was like explaining with the example like A plus B plus C. I was thinking like, yeah, the proof for that would be the same exact logic, but like different symbols. So I guess that's kind of a neat thing. Semi-groups? Oh. I might have learned about them like once when I was studying like for the GRE. I don't remember what they are though. Hey EA over on YouTube. You're doing the integral of arcsine x over square root 1 minus 5x squared to the 0? Is that right? Boo, YouTube. Nah, YouTube's cool. To the second. Okay. Wait. So should I ignore the to the 0 on the outside? I'm not sure exactly how we would do this. The arcsine makes things kind of hard. A lot of piracy? Oh, yeah, probably. Not for live streams? Yeah, it's been a little like interesting to live stream over on YouTube. Let's see if I can. So EA, I'm gonna write out the problem as I understand it and tell me if I'm right here. I don't know if I'll be able to do this. I might want to plug into Wolfram Alpha just to make sure there's an answer that isn't crazy. Actually, yeah. But let me type out in Wolfram Alpha before I go to the whole thing is squared. Really? Okay, so yeah, then I'm definitely a little bit confused what the problem is. Let me type it out, because it'll be a little bit easier for me to do it with my formatting here, and you can tell me if I'm right or wrong. So we have the integral 6 to 10. The arcsine is making me a little bit scared. I don't know how we would deal with that. Square root 1 minus 5. Oh god, Wolfram is going to be mean to me here. Okay, there. And so you're saying the entire thing here is squared? Like, oh, like, I guess there and there. Huh. That's interesting. It's complex. What? Oh, inverse sine isn't defined over 6 to 10. Yeah, this is out of arcsine's domain. Like, you can't, arcsine of 6 makes no sense. Or an arcsine of 10 doesn't either. It's on your calculus exam. Really? This? Now, if that was a regular sign on top, then we're talking. But arc sign? That's puzzling to me. And the squared being like that is super weird, because why is this square root even here then? Can you do it in definite form? Probably. All right, well, I don't know what, I mean, when I say probably, I don't know that. We could try the definite. The bounds are going to make it invalid, but we can only see what this looks like. 1 minus 5x squared. Oh, what? Wolfram Alpha doesn't even want to try. What the hell? That's kind of concerning. What if I brought the squared to each part of the fraction? Is it like this? So with more than 109 teachers based on your formula hypotheses. Why isn't it like this? So I'm supposed to do 5 times x squared? It's not going to like that. I don't like how long it's taking. Oh, what the hell, dude? Maybe it has to do with the... Oh, wait. Okay, does that work? Please, Wolfram? What the heck? Why doesn't Wolfram want to do this? Whoa. That's quite the function. All right, thanks for hanging out, Anders. Consider with more than 109 teachers based on what you form hypotheses regarding their gender, qualifications, time spent on teaching. Guess all it's all good. That's what makes sense. Yeah, the squared on the outside like that up there is super puzzling to me, and arc sign here I think just makes this impossible. If it was like, I feel like it's a typo or something. If it's just sign, I don't think it's that bad of a problem. Like, yeah, you can get a number there. But arc sign just makes it crazy. So I don't know what's up with this problem, I guess. And like, even like Desmos, it only goes between -1 and 1. You definitely can't go out, oops. Like when x equals 6 and 10, the function just isn't even defined, so. I think the problem is just bad. Here's Armenian psychologist. If you're just trying to, like, I guess, guess at the means for, like, things, then... it'd be probably, like, a z-test, which I know, but... when things into, like, actual, like, research, I get a little bit, like, nervous. That is supposed to be something fancier that I'm not aware of. It's entirely possible it's unsolvable, and that was the point. Oh, okay, yeah, if that's something that your teacher, or, you know, whatever that test is, would trick you with, then I would say that. As soon as you have an arc sign not between -1 and 1, you're just out of luck. Also, no, wait, yeah. You can't plug in 6 or 10 into the denominator there. You get square root of a negative number. So yeah, there's multiple parts of this that are just invalid. Yeah, if a trick question is on the table, this is a trick question. It's either that or a typo. Is there no 4D grapher for complex analysis? You know, if only. Dude, I was just trying to visualize something in 4D when I was in the shower yesterday, and I have... I don't know. It's so hard. I wish I could. So yeah, thanks for the question. I'm sorry, I think it's unsolvable and or a trick question, but it's always weird when I have to give that answer. I'm never completely sure of that, so. Test back in a few days, you'll see what the answer even is. Okay, yeah, I mean, it's no obligation, but if you do happen to be around, I'd love to hear if there was a way to solve this, because it's an interesting one, I guess. No DMs on Reddit. Okay, I'm glad I didn't try to integrate that before looking at Wolfram. Learn to divide in base 6? I guess so. I was getting stuck on how you do, like, I guess, like... I don't know how you do multiplication in base 6 either, I guess. But, I mean, I know the same thing, you just, you know, keep adding the number to it, but it's, like... It's not the exact thing that I'm used to. Oh gosh, you're doing an epsilon delta proof. Whenever 11 is nice. Oh, okay. Oh, Armenian psychology. I think Brian's saying that about something else. Okay, 1/11 in base 6. I guess we can try it. Okay. You do, so you find the first 5 multiples of 11 in base 6. Really? 11, 22. You do something similar in base 10. Oh no, why do you need so many zeros? Maybe it'll work out to have a nice pattern though. So the multiples of 11 in base 6. It's still 22, 33, 44, 55, just in base 6. Okay. And then you don't go to 66, you go to 106, I guess, if you wanted to go farther. Or 105. No, 101? I think 101. I don't know. Other way. It's okay, how many zeros do you have there? 110. Oh, okay. 3, 6, 10 zeros? All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, we have to come out here. We need the 5th multiple. So we take 5. Get 55. Comes out to be 45? No? That doesn't make any sense. It's because 100 is the same thing as 60. You get just 5, right? Then a 0? Because base 600 is the same as base 1000, I think. Wait, 1? Oh, you're right, 1. I see why it's 1, yeah, okay. Because that's like doing 100 minus 99. 55 is your highest 2-digit number in base 6. Okay. So in base 6, 60. No, wait, why do we at 6? I was like, that doesn't make any sense. 1. Drop a 0 down. You gotta drop another 0 down. Oh, okay, so is that gonna be our pattern? Oops. It's gonna be 05, 05, 05, 05, 05. Okay, I guess I see. It's so hard to think about numbers in different base. Now try proving 0505 in base 6 is 1/7 in base 10. Oh! I feel like I've seen a problem like this before. It involves doing a geometric series. I think I know how. Easier? I don't know the easier way. Oh, do you just convert 11 to base 6? And 1 is... That's, Oh, 11 in base 6 is 7. In base 10. Okay, that is easier. I see what you're saying now. Or not. But A equals 0.050505, 36A is equal to 5.05, 35A equals 5. Oh. (36 times A, working in base 6. Oh wait, I guess in base 10. So A is a base 10 number. Like the left side of the equation is base 10, the right side is base 6, I guess? Okay. So if you multiply the right, so multiplying the each side by 6 squared is on the right side, that means you're multiplying it by 10. So why isn't that? Oh, because it's like 100. Okay. So you shift the decimal to the right twice on the right side. Okay, yeah. And then we subtract a from each side. And you get, oh, 35. Oh, that's clever. I would never have thought to do it that way. You shift the decimal and you just lop off the infinite part. Okay. The more you know. Yeah, that is like a neat way to like do that. I don't know if we can do math for a ton longer today. Let's even find like another question though. Okay. Well, I said the first diagram is correct, I think. So I'm gonna let someone else do this. I feel like I gave my answer, but how do you show y equals ky prime means y equals ke to the x? It's an interesting question. Well, I think it should be ky equals y prime. Or wait, no, y equals... Wait, no. If you're saying like that, constant in front, I think it should be... something where, you know, I bet Obi's differential equations class will give a better answer, but at least the way that I think of it. Actually, your initial one, I mean, is also, that's smart. Okay, if you have a y equals ky prime, I mean, how I would think of it, I divide each side by k, for k not equal 0, I guess, and get 1 over ky equals y prime. And this is really just the way I think this, it's asking what function, when you derive a function, you just get its original function back times 1 over a constant. You can name that as a new constant too, but. And when you derive a function once and get your original function back, that's just e to the x. But we do have the constant that gets pushed out in front there, so by chain rule, we should know that we have 1 over k there, so that way when we derive it back, gets multiplied by that 1 over k. Oh my god. Now I feel like there's a more like theoretical answer you could give. But like this fits the format because the 1 over k matches with that 1 over k, and that y matches with that y. I guess by this fact. This is really, that's a lot of lines, but that's how I think of it. But I think maybe what you're asking about is like existence and uniqueness, which I did technically learn, but I forgot. Like, you know, how do you know there isn't some other solution to this also? Which I guess is getting into like a Picard's theorem or whatever it's called. But I think there's a way to show that it has a unique solution, and you can just figure out the solution is e to the x, or some form of e to the x, just by the form of the differential equation. But yeah, no, I feel like it's not like the best explanation, but y prime equals y means e to the x is the solution. It's because y prime equals y means literally a function is equal to its own derivative. Find that function, and that's how e to the x is defined. Yo, Bookbinder, how's it going? Glad to have you. So if you're given the problem y prime equals y, they're literally asking you to find a function such that it is equal to its own derivative. And that e to the x, you basically guess that it fits the bill because e to the x is defined to have itself as its own derivative. So you don't do some kind of algebra or calculus thing to know it's e to the x. You just think about what types of functions might work. If you had y double prime equals y, then you're talking like sine and cosine, and maybe also an e to the x. Because, you know, if you derive sine twice, you get sine back out. It depends on your definition of e. I think there's a lot of definitions of e out there. It's part of, depends on the context in that part, but at least in your normal differential equations class, you're given that e to the x, or e to the x prime is equal to e to the x, I guess. Naveen, hey, I don't know what that means. I only speak English. Sorry about that. Can you say that again in English if you don't mind, Naveen? Throw on some Juice World. I could. I won't be able to do this if you DM me because it takes a little bit too much effort to get it set up so it won't go in the VOD. But for the stuff that is released, well, I mean, I guess I can play it through. I don't know. But yeah, but Ryan, what I say, it basically is just guessing. As far as my understanding goes. And what I've learned is that I bet Zach will be able to give you a much better answer, but if you do things with complex variables, you just always guess that the solution is e to the ix, or some form of that, like maybe a piece of it, because e to the x includes sine and cosine. But you can literally take, like, you know, you can assume y equals, like, you know, say e to the kix and show that that's going to be a solution. I have a bachelor's in applied math. And a minor in computer science. But yeah, I mean, I guess I'm calling Zach because he's talked about how, like, in his differential equations class, his professor literally said, like, the solution is always e to the x no matter what. And, you know, it's like only half joking. Because it just always comes up in differential equations. How applied? We didn't really get to choose an emphasis, I guess. I guess I'll say, like, the major restructured is that, like, I guess, like, the college emphasized, like, systems of differential equations. Like, that's what I was doing mostly in my last year of studying. Well, differential equations in general too, but the thing I liked the most was differential equations and like the systems of them, and you get like matrix solutions and vector solutions. Naveen, I don't know what you're saying. I'm sorry. I need you to speak English. Yeah, I mean, I think it just by nature, a differential equation asks when a derivative of a function, some degree of a derivative, is equal to some other degree derivative of a function. And that only really ever happens with e to the x, sine and cosine. Like, if you have a polynomial, the more you derive it, it turns into something else completely. You never get the same thing back when you derive a polynomial. Same with like a logarithm, a rational function. The only things that tend to like cycle around are sine, cosine, and e to the x. So I guess you're not really there's not many other things that it can be. Polynomials can be a part of the solution to a differential equation, but normally there's still some type of e to the x mixed in there, or sine or cosine. Because like if you have the problem like the fourth derivative of y is equal to y, that just, good luck deriving anything 4 times that's not e to the x or sine or cosine and getting the same thing back. What'd you send me, Ben? Are you even listening with audio, Ben? Oh, all right. You do have audio on. Oh, okay. I was like, I think that would be classic you to tell me to like put on Juice WRLD when you're not even like listening to the stream. I guess it is Saturday. Zero plus zero plus zero plus zero is equal to 0. I would think so, Brian. I'm sure that like there's a way. The actual proof of that isn't simple though. Is this person just advertising? Oh, hey, can anyone think of a differential equation as a constant solution of 0, separate from the normal collection of solutions? What? Negative 50 plus negative 49 plus negative 40 equals 0. Imagine. I don't know what this person is asking. Numbers are in the last sum. Oh, is there... Well... It's an odd number of numbers, but one of them is 0, right? That's the trick. Even though there's an odd number of numbers, since the odd one out is 0, you're okay. Okay, I'm not finding a bunch of math. I might there are 101. Hey, I got it right. I might do some Phasmophobia now. Because there aren't like a ton of math problems, and I haven't done Phasmophobia in a while. Final question? Oh yeah, sure. We can look at that before we switch over. Oh yeah, Ben, if you want to hop in, please do. Give you 20? All right. I'm going to add 50 to all the numbers on the left. Naveen, I don't know what you're saying. Wait, how does he add 50 to all the numbers on the left? Oh, you get Gauss's sum. I get. Oh, okay. I was trying to figure out the. You add 50 to each one individually. Fair enough. So to show that if you can use negatives. So yeah, I think I'm gonna start switching over to Phasmophobia. If anyone here still wants to watch some math, I think Penn Center is going. I guess I can check that to make sure. Yeah, Penn Center is still streaming. So if you want to watch math, check out Penn Center. I'm about to do some gaming. That doesn't mean I'm going to turn off the stream on YouTube. But yeah, if you're on YouTube, I appreciate you. I'll be doing math again on Tuesday at the same time, basically 2 hours and 20 minutes ago. And yeah, thank you, YouTube. I'll see you around.